So we've seen that differentiating under the integral sign can be a useful trick to find integrals, and in particular avoid finding higher order poles. The same is true with sums. If we've got a sum which involves a parameter a, as long as the sum that we get, we can differentiate with respect to a, both sides with respect to a, as long as the sum in both cases converges. So we can apply d by dA to both sides, and this is allowed to pass through the sum. Basically, the sum of the differentials is equal to the differential of the sum. Okay, basic differential calculus rule. So we can then get this. So this is basically useful if you notice that, suppose if the sum you're asked to find has this sort of form, you notice that it could be got from something simpler by differentiating. So it's just like with the integral. So if say, for example, you've got 1 over n squared plus a squared on the bottom, then obviously you could get that by differentiating 1 over, so say you've got n squared plus a, so say you've got this on the bottom, n squared plus a squared on the bottom. Obviously you can get that by differentiating this with respect to a, you get something like that. So if you can work out this sum and then differentiate the answer, this will help you get this sum.